In this video, I'm going to prove to you where the sum and difference trig identities come from. So what I have is a rectangle. So that's a right angle, that's a right angle, that's a right angle in the bottom right corner, and then that's another right angle in the other corner. I'm not going to mark it. And I'm going to establish a few things here. So I've got these line segments drawn in. I'm going to call this angle right here beta. I'm going to call this angle down here alpha. So they do not have the same measure. I'm giving them different names. Also, this angle right here is also going to be 90 degrees. So, and finally, I'm also going to establish that this line segment there has a length of 1. Okay, so a few things that I'm going to just make assumptions for, and everything else is going to be based off of these assumptions. So first of all, this triangle that's in the middle, let's call this the blue triangle. I'll sort of highlight it in blue. So for that blue triangle, it's a right triangle because we got the right angle in it. The hypotenuse is 1, and then this angle down here in the bottom left corner is beta. And I want to find an expression for the adjacent side down here. Well, remember from SOHCAHTOA that the cosine of beta is equal to the length of the adjacent side divided by the hypotenuse. Well, the hypotenuse is just 1. So that means that the adjacent side is simply cosine of beta. And then you could probably easily figure out that the same is going to be true, or similar is going to be true for the opposite side. The opposite side is just going to be sine of beta. Okay, next thing I want to talk about is this angle right here, this angle up here. We have a rectangle, and of course the opposite sides here, so that side and that side, those are parallel. And then we can look at this side right here as being a transversal. So parallel lines cut by a transversal means that this angle is alternate interior with these angles down here. So that angle up there in the corner, that's going to be alpha plus beta up there. So let's do something similar to that triangle. Let's call that the red triangle. Okay, so for the red triangle, we have alpha plus beta there, and the hypotenuse again is 1. So the adjacent side, that's going to be cosine of alpha plus beta. And then the opposite leg, that's going to be the sine of alpha plus beta. Next, let's go over to this triangle here. We'll call this the green triangle. And I have that the hypotenuse in this green triangle is sine of beta. I want to first talk about the measure of this angle here in the corner. Now, the measure of that angle there, I'm going to put a little check mark. So that angle plus the 90-degree angle plus this angle that's unmarked, hopefully you understand that those add up to be 180 degrees. Well, if I look down here in this bottom triangle, I'm going to call this the purple triangle. In the purple triangle, that angle that's already marked with a check mark, and then the 90 degrees, and then alpha, those also add up to 180 degrees. So we can conclude that the angle in the green triangle with the check mark must also be equal to alpha. Looking at the green triangle, we know, this is the adjacent side here, and we know that the cosine of alpha is equal to the length of the adjacent side divided by the hypotenuse, which is equal to sine of beta. So if I take this equation and I isolate adjacent, I'm going to have cosine of alpha times sine of beta. And then if I do the same thing over here for the opposite side of alpha, then I know that the sine of alpha is the length of the opposite side divided by the hypotenuse, which is sine of beta. So the opposite side is actually going to be sine alpha times sine beta. Okay, let's finally go down here to the purple triangle. And so similarly, this is going to be the adjacent side to the alpha that I have labeled in the left corner. And so the cosine of alpha is the adjacent side divided by the hypotenuse, which in this case is cosine of beta. So the adjacent side is cosine alpha times cosine beta. And then finally over here, this is the opposite side of alpha in the purple triangle. And the sine of alpha is equal to the length of the opposite side divided by the hypotenuse, which in this case is cosine of beta. So the opposite side there is going to be sine alpha times cosine beta. So I have the triangle labeled the way that I want it. I said triangle, I think I meant the rectangle, the big giant rectangle. Let's go back to our properties of rectangles and remember that the opposite sides of rectangles are equal. So we could say, if I'm looking at the left side and the right side, that the sine of alpha plus beta is equal to cosine of alpha times cosine of beta plus sine of alpha sine of beta. So that leg there is the same length as this leg here, which is the sum of these two legs here. Also, if I look at the top and the bottom of the rectangle, I have that the bottom, which says cosine alpha times cosine beta, is equal to the cosine of alpha plus beta plus sine of alpha times sine of beta. Now I'm going to do a little bit of trickery on this one. I'm going to actually subtract the sine alpha sine beta, and I'm going to switch their places. So I'm going to say that the cosine of alpha plus beta, I'm going to put that on the left, and on the right I have then cosine alpha times cosine beta minus sine alpha sine beta. So these two statements that we came up with, these are two of our sum difference trig identities. So we have an identity now for sine of alpha plus beta, and we have an identity for cosine of alpha plus beta. So if I wanted to add two different angles and find the sine of the sum of those angles or the cosine of the sum of those angles, then I now have an identity that will help me do that. What if I wanted to subtract two angles? So what I'm going to do now is I'm going to take this identity here, and I'm going to substitute, instead of beta, let's do negative beta. So we're looking at sine of alpha plus a negative beta. So I'm just going to, everywhere that I see a beta, I'm just going to put a negative beta. So I have cosine of alpha times cosine of negative beta plus sine of alpha times sine of negative beta. Well, cosine, remember, that's an even function. So cosine of negative beta is actually just the same thing as cosine of beta. So this is cosine of alpha, cosine of beta. And then over here, sine of negative beta, well, that's sine is an odd function. So sine of negative beta is the same thing as negative sine of beta, which is going to make that whole term negative. So that's minus sine of alpha times sine of beta. And so this is our sine difference identity. If I wanted to do sine of alpha minus beta, then I have that identity. Finally, let's do the same thing for the cosine. I'm going to call this cosine of alpha plus a negative beta. So cosine alpha plus a negative beta. And same thing I did before, I'm going to replace all my betas with negative beta. And so again, cosine is even. So that's cosine alpha. That just becomes positive cosine of beta. And then over here, sine of negative beta, that's going to make that whole term negative because sine is an odd function. Times that negative is going to make that a plus sine alpha sine beta. And so that is the cosine difference identity for trig.